Welcome back to another exciting chemistry lessons. In the previous lessons, you learned about SI prefixes and SI unit. Well, in this lesson, we are going to combine both of them together to understand more about the values of each measurement. So let's dive in and learn about how to use both of them together. First, we have this table over here that tells the values of each prefixes. And we also have a table that tells us all the major SI unit that you are going to use for this class. So let's look at some of the common basic prefixes that we see. Well, first of all, look at the mega. Well, you have heard of mega millions lottery. That is millions, okay? Now, what is million comparing to? For the SI prefixes, we are always comparing to the base unit, which is the root or the base. And that is starting with 0. So if we look at this way, it's going to get larger. And if we go this way, it gets smaller. So let's look at some of the most basic ones that we see in our daily life. For example, let's look at this one. Let's look at over here where we have 5.7 kilograms. What does that prefix kilo have to do with kilogram? Now, the prefix kilos equal to 1,000. So we thought, hey, 5.7 kilogram, is that the same thing as 5.7 grams? Well, because we have the prefix kilo there, is basically now we're using to measure something a lot larger. Even though it's 5.7, that 5.7 actually times by 1,000 because of the prefix kilos. Or in this case, well, 1,000 what? The leftover, of course, we are always comparing to the base unit. Now look at grams. Gram is a very exceptional one. Well, that's because look at the base unit for mass. It turned out to be kilogram. But we are only going to use gram as the root. So keep that in mind. That is an exceptional one. That's why we go over them first. So we are going to use grams instead of kilograms in our SI prefixes. The same thing. And the rest of the SI unit. So let's apply this to another SI base unit. Let's use the same number. What if I have 5.7 kilojoule? Well, in that case, look at this. 5.7 times 1,000 again. Because the prefix kilos represent 1,000. And that's how prefix define the values of the unit. If your unit has a prefix, it completely changes the values of it. So we are looking on the larger end. What if we go this way? Think about it. If you don't remember, think of mega. Mega is a lot of money. Mega millions is a lot of money. And then you don't remember mega, you can think of nano. Well, think of nanotechnology. They are very tiny, okay? So nano is equal to 10 to the negative 9. If that's the case, let's look at this. What if I use the same values, 5.7? Okay, let's look in terms of grams again. So nanograms. How big is that? Well, that is so small that you can't even see it. Because that turned out to be equal to what? 5.7 times 10 to the negative 9 grams. Well, think of nanometer. Can you see anything at the nanometer level? Well, for example, we have 5.7 nanometer. What is that going to be in terms of meter? That turned out to be 5.7 times 10 to the negative 9 meter. Now let's use a calculator to understand what is the actual values of nanometer. Well, we have 5.7, okay, times 10 to the power 10 with that exponent, and that's negative 9. So we have negative 9. Look how small that number is. It's extremely tiny, okay? So now let's go back and do our problems. Well, we are going to interpret the measurement right here, okay, to find the actual values in its base unit. Again, the base unit are comparing to the root or 10 to the 0 power. Let's look how that works. Well, I have 13.9 megajoules. Well, what's mega? Mega is 10 to the 6. Now, because of the way we type times 10 to the power with the caret symbol, that is too much work. So what we do is we are going to use the E right here. That EE, or just E, represent times 10 to the power of something. In this case, we know that is 13.9. So mega, that's 10 to the 6. So we're going to put E 6. And then over here, we're going to put joule or just J. So this is the base unit, and that's the actual values in terms of the base unit. Let's try another one. We have 13.9 centimeter. So what is centi? Centi is 10 to the negative second. You see the importance of memorizing these values, okay? You don't memorize the values, it's almost impossible to solve it. So in this case, we have 13.9. What is centi? 10 to the negative second. So we use E negative 2. And then this is just meter. And that's how we interpret the values of a measurement with the prefixes to one without the prefixes. Let's try another one. In this case, we have 3.09 centimeter. And again, centi is 10 to the second. So we have 3.09 centimeter is 10 to the second. So E negative 2 and just meter. Let's try another problem. We have 3.09 centimeter. So if that's the case, centi is right here, 10 to the negative 2 again. So that's pretty easy, 3.09 e to the negative 2, and that's meter. And here we have 1.2 kilometer. Well, what's kilo? We just work with kilo. So 1.2 kilometer, kilo is 10 to the third, so E 3, and then meter. And that is how we use SI units and combine with the prefix to have a better understanding of the values of our measurement. So don't just look at number at the measurement. Look at all three things. The number, the unit, and lastly in chemistry, we look at the chemicals. And now it's your turn to try the problem on streamlineed.com. And if you have any question, raise your hand and let us know so we can help you one-on-one.